Hi, I'm Paul Blinton, President of VEC, and today we're going to talk a little bit about the services we provide to customers who are either renovating an existing space or building a new laboratory to meet the requirements of their electron microscope or other type of precision instrumentation. So the first thing we do when we have one of these projects is define what the project requirements are. That's either determined by the unique specification of a tool that will be moved into the space or a more general set of specifications based off the type of tools and equipment that this space will be used for either now or in the future. Then the second thing we typically do is we do a baseline testing of the space. And we use the project requirements that we just defined, and we evaluate the current conditions to determine whether or not, as built currently, the location meets or exceeds the requirements of the instruments. Based off that, we'll use this as a baseline to begin our analysis. Hopefully things look good, and we're really only looking at new sources of vibration, acoustic noise, or magnetic fields when we do our evaluation. Or perhaps we need to do some mitigation at this point and address existing sources which are problematic and kind of put us behind the 8 ball before the project even starts. So if we identify any red flags during the initial site evaluation, one of the benefits of working with VEC compared to some of the other options available on the market is we're going to identify the specific reason why your site did not meet the project requirements. So if it's an EMI failure, we're going to identify the specific source of that EMI. If it's vibration, we're going to do the same. That kind of leads us with a decision to make at this point. We kind of have 3 paths forward. We can either try to mitigate or remove the source. So back to our piece of electrical equipment, perhaps that electrical equipment can be moved to another location as part of the project scope, and that will mitigate our EMI issue. Or the second course of action is perhaps we can meet the project requirements, but it's going to require mitigation equipment. So you're located next to train tracks, the train's problematic, it's causing the vibration to exceed the requirements. No matter what we do, you're going to need active vibration isolation platforms to meet the project specifications. And so that's something we would identify immediately and early on in the project. And then third, and we try to avoid this whenever possible, is perhaps the location that's chosen and that we tested isn't really suitable for the type of instrument that you want to install. At this point, we'll flag that. We'll be honest with you about our findings and recommendations, but we do feel it's valuable to identify that if a location is not going to work, it's best to identify that early on so we can make adjustments and suggest other more suitable locations at this point in the project. So we've identified a location, and we either have a plan for mitigating sources that we identified during the initial site testing, or we're in a good place and those don't exist. So now we need to focus on new sources that are going to be introduced through the construction and the design of the project. And so at this point, there's really 2 primary services that we offer to our customers. The first is acoustic modeling, and the second is EMI modeling. So the first type of modeling that we're going to discuss is EMI modeling, so AC and DC magnetic field modeling. For DC magnetic field modeling, we have a pretty robust database of different sources of DC magnetic field, or changes in DC magnetic field, and we can use that to overlay the expected DC magnetic fields on the project design. So if you have an elevator that's going to be going in, based on the size of elevator, we can determine kind of what the magnetic field is going to be at different distances away from that elevator. Now, AC magnetic fields are generated by electrical equipment, AC electrical equipment, 60 hertz, and it really depends on the loading, type of equipment, and shielding of that equipment to determine the magnetic field at different places throughout your facility. And so at this point, what we would do is we'd look at all the planned electrical equipment, the routing, and the loading, and generate a 3D finite element analysis model of your space. We would do an initial run based off the planned electrical plan and the requirements, and we almost always find something that could be improved. We really have a collaborative approach with the electrical team, and there's a very healthy back and forth of which piece of equipment needs to be moved to make the space more compliant to the magnetic field specifications, and which is fine. At this point, once we've made the magnetic fields the best we can, hopefully we are within the specifications of all the instruments that are going to be going inside the facility. If we're not, at this point we start looking at remediation options, and those are typically passive shielding or active magnetic field cancellation systems. And so for passive shielding, we can actually shield the room. We can model that with our 3D FEA software and ensure that we'll be in compliance. And we have a significant amount of field testing data and experience with active magnetic field cancellation systems. And that's often an option that's used at this point to ensure that we meet the very specific requirements of your instruments. So the second type of modeling we're going to talk about is acoustic modeling. And for acoustic modeling, it's important to understand the three pathways that noise enters into your laboratory or the room designed for your specific piece of equipment. The first pathway, and typically the most problematic, is mechanical noise that enters the room through the supply and return ductwork. And so for this type of modeling, we'll look at the manufacturer sound data for the mechanical equipment. If that's not available, we can take data of existing equipment that will be reused. We'll actually model the noise as it moves through the ductwork. Any sound attenuators will be considered, the diffusers will be considered, any turns in the ductwork will be considered, and then we'll do the same on the return side. And that will allow us to get the total noise based off the supply and return in the room from the mechanical equipment. The second pathway of acoustic noise entering a room is through the walls. And so these facilities have a significant amount of mechanical equipment that generates noise to support operations, either for the tool or for the equipment itself. If manufacturer sound data is available, we use that. If not, we have a big robust database of noise data for chases, etc., that we can use. And we'll look at the specific wall construction and ensure that the wall construction is sufficient to mitigate the noise from entering in the room. We'll do the same for the doors and the ceiling as well. Windows too, if that's applicable. And then finally, we need to look at the reverberant noise in the facility. Reverberant noise is basically noise that bounces around the room. So instead of hearing the source of noise once, you hear it 17 times as it refracts around the hard surface of the room. There's some guidelines for what the reverberation time should be for different applications. And we can actually do a saving calculation, calculate the reverberation time, and assess whether or not it's sufficient based off the laboratory or the room's application. We'll then take all these different sources of noise and combine them to give a total noise level for the room. And one of the things that we do that's different from some of the other acoustic consultants out there is that we will take that total noise calculation in the frequency domain and compare it to the unique tool specification based off the equipment that you plan to install. And so what you will get at the end of one of our acoustic modeling projects is what the total noise is in your room based off the modeling we conduct, and we'll compare it to the unique tool specification line and make sure that it's kind of meets your project specifications. If not, obviously we'll have a back and forth with your mechanical team and your architect to bring the noise level within the requirements. But we're going to look at this through the lens of your tool specification, which really differentiates us from others on the market. So in addition to the acoustic noise and EMI modeling, we'll also provide some guidance when it comes to product selection. So examples of that would be, we'll provide some guidelines on specific door construction, what the SDC rating should be, things like that. For sound absorption material on the wall, we'll provide a sound absorption coefficient, sound transmission coefficient if it's needed, or sound panels on the wall. And we'll identify equipment that should be on isolators, whether that's the mechanical equipment on the roof or specific pieces of equipment in the chase. We want to allow the design team and the customer to make the decisions on the fit and finish of the room, so we don't necessarily provide specific product recommendations. We just want to make sure that the product selection will meet the requirements of the instruments so that they can perform optimally in their new lab. Once the design is complete and construction is done, we'll do a final site validation against the unique tool specifications to ensure that what we design meets the project specifications and that the tools and instruments will operate optimally in the new facility that we just designed and built. If you have any questions, there's a lot of information available on our website, www.vibeng.com. I encourage you to check it out or give us a call if you have any questions. Thanks, and we look forward to working with you on your next project.